Alright, in this video, we will be talking about, well, force with angle along a horizontal plane. These questions, we'll be answering them, and yeah, maybe I'll stick to this part first, and I'll continue with the next kind of lesson for the next video, as well as for the third, which is about tension. So let's start first with number one. So a Ninja van rider, or basically a delivery rider, drops a 10-kilogram box while the motorcycle is running, but was still attached and pulled by a rope with 120 Newton force at an angle of 36 degrees. So how do we draw a free body diagram with respect to what was stated? Well, first things first, actually, I'm supposed to remove this, but I'm not sure why it's here. But yeah, let's try to redraw it again. Not sure why. For a while. Rebooting. Where is it?
You cannot use that for you cannot
Alright,
use that.
so let's redraw it again just to be sure that if you're copying notes right now, it would be helpful. So first, let's draw a rectangle. So this should, or maybe a box. It's more sensible to put a box, but I'll put a rectangle anyways. That detail doesn't really matter that much. So we have 10 kilograms, that would be the mass. And I believe this is the surface. Perhaps the road, the asphalt. And say this is the motorcycle. Apologies for my drawing. So yeah, just pretend that this is a motorcycle, and then there is a pole. So we'll place another dash line here for the surface with respect to the angle. Sorry about that. Okay, so from there, of course, we write the frictional coefficient. That will be important for later. These two formulas will also be important. We have to calculate, for part A, we have to calculate the values of FAX and FAY. How? Utilizing these two formulas. By the way, the 120 newtons, that is supposed to be our FA. How do we draw that in our diagram? This is FA, the force where the arrow is directed towards to. So FA is going this direction, and its magnitude, or its value, is 120. Wonder what's wrong with my pencil. Anyways, okay, I don't really have to place that motorcycle anymore, but yeah. Now we end up with this kind of illustration. So we do have all the things that we need to look for FAX and FAY. So FA is 120 newtons. Cosine, our theta value, is the angle. So it's 36 degrees. And by the way, just to let you know, in this kind of diagram, it says pull. So naturally, the arrow of FA is going from the object towards its direction. But say that it's push, which is going to be the topic for the next video, next worksheet. The arrow is supposed to be like this, in a way. Pull is usually this way, push is usually that way. So FAY, by the way, you could already find the value of FAX. So if you have your calculators with you, so 120 cosine 36, that is equal to 97.08204. And then don't forget the unit, it's meters per second. We're still, sorry, not meters per second. We're talking about force. So the unit is supposed to be in newtons, just like weight. So For FAY, 120 newtons sine 36 degrees. What's the value? We have 70.53423 newtons. So we have already found FAX and FAY. I have to be honest, I'm not really sure what these are. But if I remember correctly, these values in the illustration, they're basically this. This one is FAX, X with respect to the x-axis, FAY with respect to the vertical part of the illustration. Okay, so we have to calculate the weight. We always know that the formula for weight is mass times gravity or gravitational acceleration. So weight times the mass. It is known that the mass is 10 kilograms, so 10 kg, times the gravitational acceleration, which is 9.8 meters per second squared. We don't really have to use a calculator for this. Just move the decimal point to the right because we have 1 0 over there. So 98, I believe. Yeah, it's 98. So kilogram times meter per second squared is basically Newton. So weight is equivalent to 98 newtons. So for the summation of Fy, actually wait, we have to compute for the normal force of an object. And to look for normal force, which is this one, we utilize the formula summation of Fy is equal to normal force plus Fay minus weight. Why do we use this? Well, I believe we already have everything. We have the weight, the Fay, but for this, let's see what we can do. It says in the scenario, there is friction. The box is definitely moving with respect to the with respect to the horizontal part, but it isn't flying or anything. It's just sitting on the surface of the asphalt road. So the summation of Fy is supposed to be 0 newtons. But definitely, the summation of Fx, the movement of the same box in the horizontal aspect, it's definitely not 0 because the object is moving. So newtons, normal force plus Fay, which is 70.53423 newtons. We minus it with the weight. Now, 70.53423 minus 98 is equal to negative 27.46577. Transpose that to the other side, we get a positive value of the same thing. So positive 27.46577. What is the unit for normal force? Still newtons. Because technically it's still a force. Or if it somehow feels confusing, you can just put Fn. Normal force can also be written as or abbreviated as Fn. Let's see if I have it correct so far. Where is my... I believe it's this one. My review were for... maybe not that. This one. Okay, 27, correct? Yeah, so far so good. Okay, so we calculate the friction if the frictional coefficient of the object of the surface is 0.3. So frictional coefficient is 0.3. And what is our normal force? So 27.46577 0.6577 newtons. So friction is equal to 8.23973. What is the unit for friction? I'm not sure. Let's see the answer key. Newtons. Alright, that's interesting. So friction has also the same unit as force and weight, which is Newton. So we have to calculate the acceleration of the system according to the x-axis. Summation of Fx is equal to ma. Always remember to memorize that formula. So what's our mass? 10 kilograms. What was seen earlier. How about the acceleration? Mm, F is equal to ma. I believe this is 120 newtons. Am I right? Nope, I am not right. Wait. We're supposed to solve for letter E first before F. Okay, so summation of fx, like what I said earlier, is definitely not equal to 0 because the object is moving with respect to the x-axis or the horizontal aspect. So Fax or Fa is 120 newtons. The friction is 8.23973 newtons. What's the summation? So we have 111.760 newtons. Now we have the summation of fx. We can now use that to find the acceleration given this formula. So 111.760 newtons, and then we have acceleration. We have 11.17603 meters per second squared. The unit for acceleration is meters per second squared. Let's see if I got it right. Where did FAX come from? Oh, okay. Never mind. Please disregard what I said. FA is not equal to FAX. So, what value did we find earlier about FAX? It's this one. So we just subtract these two values. 97.08204 minus 8.23973. We have 88.84231, and then the answer is 8.884231 meters per second squared. Okay, so far so good. On to the next video for the next question. Thanks for watching.